Okay, so last time we finished up on this one. We have a convergent boundary coming together, causes compression. Notice here where it's pressing down, and you're forming basically a series of thrust faults in a way as they're stacking up on top of each other as the materials are basically being stacked up, right? Okay, so those are examples of thrust faults in a convergent boundary. Same thing can happen when you have two continents coming together, right? Two continents coming together, you're going to have thrust faults on both sides here, okay, as they are basically pushing up on top of each other. Some stuff goes, the hanger wall goes up, footwall goes down, forming these nice little thrust belts on both sides. And in the same process, we're going to have a lot of metamorphic rocks and ductile deformation further down, right? We had that in the same one on the other side too. We'll have kind of ductile deformation, metamorphic rocks forming down in this area here. I didn't show it in this image, but it's still there. In this one, it shows it a little bit better because it's deep down, higher pressures, higher temperatures. You're going to have ductile deformation in these regions and more the brittle deformations out here, where it's shallower and colder. Okay, so now realize that this kind of goes along with that same idea. When you have collisions of these mountain ranges, these mountain belts, you can have, first of all, igneous rocks being forming because of the melting that occurs when you have two plates coming together, right? Okay, but then you also could have the metamorphism that because of the ductile pressure and the changing of the rocks there. So the rocks metamorphosed are at depth, move toward the surface on faults due to plastic flow. Okay, and then as these rocks, the igneous rocks and the metamorphic rocks start to erode away, you tend to have the sedimentary rocks on the edges of the range. Right? So they're all, the rock cycles all kind of all working together in this cycle. Okay, now the last one I wanted to talk about is what we call the accretion of what we call exotic terranes. We've talked about this when we talked about plate tectonics a little bit, but I wanted to relate this back to structures a little bit. So here's this terrain or an island arc maybe coming in, slamming into the coast. And then it gets sutured. Now a suture basically means it's that point where it used, this used to be a different plate or a different part to this other one or an extinct arc. Okay, so these materials are being basically attached to the rest of the continent. A great example of this is here in North Carolina. This same thing has happened. When we, back prior to the Appalachians being formed, we had North America here. We had what we call the tectonic volcanic arc that slammed into the coast, forming what we call the tectonic orogeny or tectonic mountain belt. Then we had Avalonia slam in, okay, forming some more mountains. Then we had Africa slam in to form the Alleghanian orogeny, right? Okay. Then after that, everything got split apart through divergence, and so it's being pulled apart. So in North Carolina, we have lots of old thrust faults that were present a long time ago when these got slammed into each other, but we also have some normal faults. As it got pulled away, it broke apart to form normal faults. So we have both normal faults and thrust faults, but we have more thrust faults than we do normal faults here in North Carolina, just because of the formation of these big mountain belts caused by the collision of these materials. So, so that's an example of this. Now realize that all our continents, that's how our continents were formed. Our continents were formed like this. They're just basically a bunch of these materials coming together. I'm going to skip this slide here and come here first. So really North America is an amalgamation of a small little continents slamming into each other to actually forming this larger continent over time. So you have all these rocks in North America, and in the interior of the continent are made up of these old rocks. Okay, and the outside edges, the part where we live at, are quite actually young relative to the central core. So the central core is what we call the Craton. It's the continental lithosphere that has not been affected by mountain building for a long time. It was billions of years ago, but now it's not actually active anymore. This is why it's all flat in a lot of areas. It's been slowly eroded away, and all you have left is this big, what we call Canadian shield. The shield is where you have the actual Craton that's been exposed, okay, which is often these Precambrian metamorphic and igneous rocks, whereas the Craton is the whole thing that's both exposed and with sediment on top of it. If it's sediment on top of it, we call it a cratonic platform. If it's exposed, we call it a shield. Okay, so the Craton is just one large old piece of lithosphere. That's and just a bunch of these continents, small continents and islands slamming together over time. Okay, whereas the shield is the exposed portion of that. This platform is where all the sedimentary rocks are on top of it. Okay, so here in North Carolina and around our neck of the woods, this shield, okay, and these layers, the platform has been altered because of the collision of these rocks over time. And as it did, it's actually just like in a big rug or something like that that's getting pushed on. Some parts go up, some parts go down. You end up forming these basins, okay, and domes. So you can see them all over the place here. We have an Appalachian Basin on the other side up near Pennsylvania, okay, in the rocks. We have what we call the Cincinnati Arch. Most of this is underground. It's been kind of planed now. And so most of this is flat now, but the rocks are actually dipping up and down still because they're the remnants of this old bending of the Craton. Okay, so that's what you can see throughout this region. Now, hopefully that made sense. Some people have a hard time with this section just because some of it is so visual and you have to think of things in 3D, and some of you guys don't think of things in 3D very well. I understand that. So you might have to actually practice this a little bit to be able to understand it. Maybe think about grabbing some blocks or just get two rocks or something like that. How does it relate going up and down to each other? Which way is the hanging wall? Which way is the foot wall? If it requires you to do some thinking about it in 3D and you do it yourself, that might be able to help you out a little bit. Okay, so that's all for this week. If you have any questions, as always, please put it in either the general question discussion board or shoot me an email. Okay, guys, talk to you later.